Hello there, welcome to the AS Maths June 2023 paper, the applied paper. Here we're looking at question 1. So two children, Pat and Sam, run a race along a straight horizontal track. Both children start from rest at the same time across the finish line at the same time. In the model of the motion, Pat accelerates at a constant rate for 5 seconds, 5 seconds, I can see that, until reaching a speed of 4 meters per second, and then maintains a constant speed of 4 meters per second until crossing the finish line. Sam accelerates at a constant rate of 1 meter per second squared from rest until reaching a speed of x, and then maintains a constant acceleration of x, constant speed of x until crossing the finish line. Both children take 27.5 seconds to complete the race. The velocity graph shows the velocity graphs shown in figure 1 describe the model of the motion of each child from the instant they start to the instant they cross the finish line. Okay, that's all making sense. Use the model to explain why the areas under the two graphs are equal. Okay, so the areas under the two graphs are equal because in the description of the question here, it says they cross the finish line at the same time, i.e. they've travelled the same distance during that time, and the area under a velocity time graph represents the distance travelled. So put all of that together into some sentences. Part B, find the acceleration of Pat during the first 5 seconds. So acceleration is the change of speed over time. So Pat gets up to a speed of 4 meters per second from an initial speed of 0, divided by how much time he took to do that. So the answer there is 0.8 meters per second squared. You can either use this SUVAT formula or work out the gradient of the graph for Pat. Find in meters the length of the race. Well, let's use Pat's graph because we've got more information about that. So we're going to work out the area under the graph. So we're going to start off with this triangle on the left hand side. In fact, we could just go for the whole thing. We go for a trapezium shape. So you see here Pat's the graph of Pat's shape is a trapezium, so we're going to go with that. So the formula for area of a trapezium is it is the top two lines added together. So it's going to be 22.5 add 27.5 divided by 2 to find the average of that, and then we multiply by the height of the graph, which is 4. Okay, so let's reach for the calculator and calculate that. 22.5 add 27.5 divided by 2 times by 4, and we get 100. It's a 100 meter race. 100 meters. Excellent. Right, find the value of x given your answer to 3 significant figures. Okay, so what we're told in this question is that Sam accelerates at a constant rate of 1 meters per second squared. So what that means is that Sam's acceleration was much faster than Pat's, but he doesn't really reach a top speed as great as Pat. So what we're going to do then is we're going to call we'll call this value t for time, and we're going to use the fact that this area under this graph should also equal 100, but we're also going to use the fact that this line here should have a gradient of 1. So in fact I don't need to use t, I could just use x, because this value here should be exactly the same as that value there, because the gradient is 1. So however much you've gone across, you should be going the same amount upwards, and if we've gone upwards by x, we need to be going right by x. So we've got an x here as well. Okay, that's quite helpful. So we're going to use the same formula for the area of this shape. Would that be the easiest thing to do? No, I think actually for this question I'm going to divide it into a triangle, and then we'll do a rectangle added onto the side. So the triangle first, that's going to be a half base times height, so that's half x squared. Add the area of this rectangle, which is going to be 27.5 minus x. That's the base times the height, which is x. And this is going to equal the whole thing, the whole area added up together is 100. Okay, it looks like we've got our quadratic starting to form here. So let's first of all expand the brackets. So it's going to be add 27.5 x minus x squared equals 100. Let's multiply everything by 2 to get rid of all of these halves. So x squared add 27.5 times 2, which would be 55, minus 2x squared equals 200. Okay, that's looking a lot easier. Let's now move everything onto the right-hand side. So x squared minus 2x squared is minus x squared, but then we're going to add it to the other side. So it's x squared here, minus 55x, add 200. Okay, so let's pop this into the calculator to solve it as a quadratic. So we're solving this as a quadratic. Okay, bear with me, and we get x equals 3.92. Yeah, 3.92. That's the only solution that's going to be less than 4. The other solution was more than 4. So the answer to this question here is x equals 3.92 to the 3 significant figures we've been asked for. Lovely, so there we are. That's the answer for question 1 from the mechanics section. Let's now move on to question 2.